Hello everyone! Today we are going to be looking at the structure of the nuclear atom. So if you remember the last time we were speaking of Dalton's atomic theory, and most of it is accepted today. However, there's one big change, and that is that number one, which was according to Dalton, that atoms were not divisible. However, we now found out that they are. They can actually be broken down into even smaller particles, which are called subatomic, sub meaning below, and atomic meaning atom. So below the atom surface, you have these different particles. And the particles that have been discovered are electrons, protons, and neutrons. Electrons have a -1 charge, and their mass is so small that we typically don't even incorporate it into a lot of our equations. Then there are protons. Protons are going to be +1, and their relative mass is about 1, so they're much, much larger than that of the electron. And finally, we have the neutron. And that sounds a lot like neutral, so that's how I remember that it has a relative charge of 0. And it's about the same size as a proton, so you can see that they are right around the same size. It is important to know each and every one of the charges as well as the relative mass. That's because in all atoms have equal numbers of electrons and protons. So protons are equal to the number of electrons. So the interesting thing about that is since the number of protons is equal to the number of electrons, that means that the charge of an atom is always neutral. And that'll come more into play in Chapter 4, Section 3. But for right now, we need to make sure that we know that there are 3 different types of subatomic particles, and 2 of them, electrons and protons, have a charge. When they were first discovered, scientists wondered how on earth these particles are arranged. So the first person that kind of came up with their theory was J.J. Thomson, and he came up with the idea of what is called the plum pudding model. Another idea is that of a chocolate chip cookie. So in this example of the chocolate chip cookie, all of the chocolate chips are just like the electrons, and the dough is just a positive charge. Now, the reason he didn't say protons, because in the previous slide, we figured out that protons are the ones that are positive. But the reason he didn't tell us that the dough is the protons is because Thomson didn't know. He didn't know about those protons. It wasn't until one of his students, Rutherford, performed an experiment to really help understand the nature of that atom. So in Rutherford's experiment, which this experiment is important to know, by the way, in this experiment, you have a narrow beam of alpha particles, and all an alpha particle are 2 protons. Okay, so that's going to have a +2 charge, just so you know. And they took these alpha particles and they shot them at a piece of gold foil. Now, gold is made up of atoms, just like everything else, and this is a specific type of gold that is of all the same consistency. So it's not mixed with anything else. It is a pure substance. And when it was shot at this gold, he made a prediction based on Thomson's work. According to Thomson's plum pudding model, all of the beams should go directly through the gold and hit the other side, since for the most part, it was, well, negative. It wasn't going to be believed that it was going to be changed direction that much. However, he found something surprising. He found that a small fraction of these alpha particles, which are the red beam here, bounced off the gold at very large angles. So he would see the alpha particle come in and get deflected instead of what he predicted, that it would go straight through. So the idea of the alpha particle going straight through is based on J.J. Thomson, but Rutherford found something different. He found these alpha particles were getting deflected, or even more surprisingly, they were getting bounced straight back at the source that was shooting out these alpha particles. Based on these findings, he suggested a brand new theory. Instead of the idea of J.J. Thomson, which looked something like this big blob of positive and then random negatives all around, so it looked a lot like a chocolate chip cookie. Instead of this model, Rutherford came up with a new idea. He said that there must be a central area full of positive charges, and these atoms were mostly empty space. So you have some negatives surrounding that atom, and this small central region called the nucleus was responsible for the alpha particles. So that alpha looks like this, for the alpha particles hitting and coming back at the source from which they were shot. So here is another example, a lot better drawn, of course, of what J.J. Thomson's looks like and what Rutherford's atom looks like. I'd recommend that you know these differences. So you can see that all the positives are in this general central region called the nucleus. And instead of all the electrons being randomly dispersed, instead you have them in these specific areas surrounding the nucleus. And for the most part, it's empty space. Rutherford actually turned out to be fairly correct. However, it was a little bit incomplete. They had to revise their ideas a little bit to include things like where the neutrons were important. So remember, the neutrons are neutral, so they don't have a charge. They also wanted to kind of understand how electrons were arranged. So that was also explored later on. But for the most part, the general outlook of Rutherford was fairly correct. And it is this general model that we use today. So at the end, as always, we have some great glossary terms for you. So if you want to, you can always copy those down in case you're having any troubles. And we'll talk about this more tomorrow.